Good morning, everybody, and thank you so much for joining us. Today, we are going to be talking about how to determine the physical properties of matter. How can we describe it? How can we measure its physical properties? And we're going to be focusing on these 6 categories. Now, not all of them we will go into horrible detail on because not all of them require tools to be measured. So let's start with solubility. So solubility is defined as a matter's or substance's ability to dissolve in water. So to determine its solubility, you stir the substance in water to see if it dissolves. So for instance, if you wanted to do an experiment to see the solubility of salt in water, which we know salt is soluble in water because the ocean is one giant vat of salt water, you would take water, a certain measured amount, and slowly but surely you would introduce salt in specific measured amounts until the water could not physically absorb any more salt, which is one thing that I do plan on us looking at as an experiment. So solubility. All right, relative density. So for relative density, you put the substance in water and see if it sinks or floats. So if something is more dense, it sinks. If it's less dense, it floats. So for instance, if you took a loaf of bread, and if any of you have seen the Magic School Bus episode that my mind is thinking of, the students are at a lake and one of them throws a loaf of bread onto the water and it floats. And then a few moments later, they take it and they crumple it up into this bread ball and they throw it in the water and it sinks. And they determined that the balled up slice of bread is denser because all of the mass in the bread is compacted tightly. And because of that, it turns it into a piece of matter that is more dense than water. So it sinks. So the more tightly compacted the matter is, the more dense it will be and the more it will sink. And I just realized that this Y did not get extended properly. There we go. That was going to bug me. All right, so next we're going to look at mass. Mass is the amount of matter in something. So to determine mass, you can use a triple beam balance or a double pan balance, and it's measured in grams. We're actually going to be looking at a triple beam balance and how to use it here in just a few moments. For thermal conductivity, you're talking about the amount of heat that it can conduct. So if it is a thermal conductor, it will allow heat to travel through it. If it is not a thermal conductor, then it is the opposite, making it a thermal insulator. So to test whether it is a thermal conductor or a thermal insulator, you would wrap the substance around ice to see if the ice melts. If it melts, it's a conductor. If it doesn't melt, then that matter is an insulator. Same concept with electrical conductivity, which we've tested when we were looking at circuits. You place the substance in a circuit and see if it allows electricity to flow. So if electricity flows through it, such as an iron nail, wires, pipe cleaners, things like that, those are electrical conductors. But if you put, say, an electrical circuit and you put in a piece of orange sponge or a marble or a hot glue stick or a matte pencil, those things are not electrical conductors. They are insulators. So if the electricity flows, it has electrical conductivity. If it doesn't, it is an electrical insulator. And the last piece we're going to look at is magnetism. Now for magnetism, you simply place a magnet up to the object and see if the magnet is attracted to it. Now, magnetism involves the amount of iron within a substance. If the substance or the matter does not have iron in it, it is not going to be magnetic. Okay. So, for instance, if you took a magnet and you put it up against the door of a refrigerator, we know that refrigerator doors are magnetized because magnets will stick to it. But if you took a magnet and you put it up against a glass window pane, that would not be magnetic because glass does not have iron in it. All right. So we will be diving more into magnetism a little bit later in another video. We're going to be looking at the measurement tools for relative density, for mass, and for temperature. Temperature is something that's not listed in here, but it is a tool that we're going to look at. All right. So our first tool is the triple beam balance. Let me zoom in a little bit and get our focus into gear. All right, so a triple beam balance is something that you've seen before. We will be using a triple beam balance in class because we are going to measure certain properties of matter in an experiment a little later on. What you need to know are the parts of a triple beam balance. So the first piece is going to be the tray that the substance or matter sits on. In this instance, in this image, we have a rock sitting on the tray of our triple beam balance. You also have the base of the triple beam balance that everything is attached to. You have the adjustment knob, the beams, which there are 3 of, one for grams counting by tens, one for grams counting by hundreds, and one for grams counting by ones. Now on the beams, the things that I've colored green are called the riders. They are what you use to actually measure the mass of a substance or matter that you place in the tray, which I'll explain here in a moment. Then you have the pointer and the 0 mark. Now, this whole arm right here is free floating. It will bounce up and down. So before you put your matter on it, you want to pull your triple beam balance out and you want to make sure that after it settles, that pointer is pointing at the 0 mark. You cannot start measuring unless it is zeroed out. Okay. If it is not zeroed out, you have to use the adjustment knob to loosen or tighten this beam in order to get it leveled and zeroed. Now, once it is leveled and zeroed, you'll put your matter on the tray. What's going to happen is this matter is going to push down on this portion of the bar, and it's going to cause your pointer to pop up. So then you will start with your hundreds, or the rider that counts by 100 in that center beam, and you'll slide it to 100. So that's going to add weight to the end of the beam. Now, if it comes down a little bit, remember you want it completely even eventually. So if it's popped up and you add 100 and it goes down a little bit, try sliding it to 200. Now at 200, if it goes completely down and your pointer drops below the 0 mark, then it's too heavy. So you take that back to 100, and then you would go up to your 10 rider. And you would slide the 10 rider to 10, to 20, to 30, and 40, it may knock it down. So once again, if your pointer drops down below the 0 mark, you've added too much weight. So on this one, they took it back to 30, but it still wasn't zeroed out. So they used the 1 rider and they slid it out just about 3/4 of the way between the 7 and the 8. And that leveled the bar out at the 0 mark. So the pointer is even with the 0 mark. So this means that this rock, you calculate the mass of it by adding the 30 plus 100 plus the 1's rider, which came out to about 7.7 grams, and you add those three amounts together to get your total. So the mass of the rock is 137 and 7/10 grams. And again, we're going to be testing this out a little later on by using these tools to actually measure the physical properties of some items together in class. So let's take a look at our next one. The next one we're going to look at is relative density. Now, relative density to me is kind of fun. I've always loved density because it's simply the ability for matter to sink or float. And so in this example, we have a beaker. It's measured in milliliters. And there is 2 objects and 2 liquids. Okay, we have a block, we have water, we have a bead, and we have oil. Now, the biggest thing that you have to remember when looking at relative density is that the more it floats, the more towards the top of the liquid you get, the less dense it is. And the deeper you go into the liquid, the more dense it is. So in this case, by looking at this, the block is more dense than water. The water is more dense than the bead, and the bead is more dense than the oil. Okay, and we can even look at it this way: more dense to less dense, the block, followed by the water, the bead, and then the oil. So the more it floats, the less dense. The less it floats, the more dense. All right. Our next one is volume of irregular shapes. Okay. So to find the volume of an irregular shape like this rock, you're going to fill a graduated cylinder to a certain point with water. And in this case, they filled it with 30 milliliters of water. And then they put the rock in. Now, I'm going to give you a couple of seconds, and I want you to think, what has happened now that this rock has been put into the water? All right, so if you said that the water level rose because the rock displaced the water, you would be correct. Correct. So think about it like getting into a bathtub. You fill the bathtub with water, and when you get in, the water level rises even more. That's because the water is being displaced. And in this case, the water started at 30 milliliters. It was displaced up to 35 milliliters. And so now we simply have to do a small subtraction equation. So we're going to start with the 35 milliliters to what it rose to. And we are going to subtract the 30 milliliters that it started with, because the water was 30 milliliters. We're not adding to the water. We're not taking it away. It's staying at 30 milliliters. The only thing we've done is add the rock. Therefore, we take the entire 35 milliliters, we subtract the 30 milliliters of water, and we find out that our rock has a volume of 5 milliliters. And this can work with any object as long as you can fit it into a graduated cylinder or a cup or something that has measurable milliliters on the side. All right, last but certainly not least, we are going to take a look at temperature. Okay, now in science, we use Celsius, and there is a very specific reason for this. So freezing water in degrees Celsius is 0 degrees. That's pretty easy to remember, right? Well, if it's freezing, it's at 0. Room temperature is at 22 degrees Celsius, and it boils at 100 degrees Celsius. Now, not a lot of people are going to take the time to memorize that, well, room temperature water is at 22 degrees Celsius. But if you remember that it's frozen at 0 and it boils at 100, that's pretty straightforward. But in Fahrenheit, freezing is at 32 degrees and boiling is at 212 degrees Fahrenheit. Which numbers are easier to remember? 0 and 100 or 32 and 212? If you're like me, this is going to be easier. So just remember that when you're looking at a thermometer, the mercury inside the thermometer is going to tell you the temperature. Do not break thermometers. Mercury is a very poisonous type of matter, and it can be deadly. So if you ever accidentally break a thermometer, immediately get an adult. If you ever get mercury on you, call poison control, call your parents immediately, call 911 to make sure that you stay safe. So you're simply going to look at where the top of the mercury has risen to, and whatever number is next to it, that's where you measure the temperature. Okay. All right. Well, thank you guys so much for joining us today. I do appreciate it. I hope that you have a better understanding of how to measure the physical properties of matter. We'll be looking at a couple of examples of how to do this in class later on. Have a great day, guys. We'll see you next time.